Hi, this is Mark, AJ6CU. Today I want to review some of the features on the uBITX setting editor that I just recently released, and give you kind of a hint on how you can use it. So, why is there a settings editor? Well, it's kind of, when you get in a car, first thing you do, you adjust the seats and you adjust the mirrors. Well, when you get a new radio, you need to tailor it towards what you need, not only key speed, and side tone, but there's also things like what are your favorite memories that you want to, station memories you want to be coming back and forth. What are your call sign? There's a whole host of things that you may want to tailor. And some of you, it's true, you can do it on the KD8 CEC enabled radio, but there's actually a lot easier way to do it. And that's why we're going to show you the uBITX setting editor here. So I'm going to start it. And when it comes up, you'll notice that there is four areas. There's this up area here, which is where you select where your input's going to go. Down here is where you're going to write things. Here's a log, which is when the interesting things happen, it's over here. And then here's where all the settings are going to be. So let's connect to a radio. So I happen to know that this radio at COM port 3 is is a Teensy based uBITX. As you can see, we're starting to read things in the on the log here. One of the things that is there's a sanity check over here, which it actually looks at your calibration numbers and then sees whether they're proper for the board that you have. So now we've got some interesting things in the middle, and you have a set of tabs here that allows you to go to collections of things. So for example, here is a general setting. It's where you put your call sign. My call sign's here. You can select what is the tuning rate. And in this case, we have, we don't want 10,000, but we'll put it at, let's see, which one's my favorite here? My favorite here is this one here. And I'll make my default step 100. So here, down here, your key type, I like 700 hertz by side tone. I'm also one of those people in the CW areas where when I send, I want to see what I'm transmitting on. So then we can go down to a keyer. So the next tab is really about setting up an automated keyer so that you can actually do a lot of the work for you if you're doing CW. You can set up a bunch of messages. They're up to about 200 bytes of messages you can send. There's some macros over here where if you put a greater sign in here, when you send out the message, it'll replace the greater sign with your call sign. There's some obvious things here, some BTs and stuff like that. Pretty cool. And then you can go down here and where the bands are defined. Now, obviously, microbit's sold in many different areas, and the question is, what are the bands that are appropriate or legal in your area? So for the Americans, you can just fill in, click region 2, and you're all set. Next section talks about channels. So you can set up channels, which allows you to move to them, an area that you like to be at, or maybe your friends are like to be at, and so you can meet them very, very quickly. And you can have frequency, you can have a name, you can show what the mode is when you get there. And there's 10 here, but there's also another 10. If you click the show extended channels, there's another 10, they just don't have any names. So you just got to remember this channel 12 is something. The next tab is how you set up Whisper. So that as a situation where you actually, for example, send a message, and we'll come over here. So I would put my call sign here, AJ6CU. Oops, okay, click in there, AJ6CU. Let's pretend like we're in QM17, and then I would generate a Whisper message, and that's here. And then I can name the message. So I can name it to be, maybe my call sign, AJ6CU. Okay, and then you can select what bands you're going to be running on. So this is another little nice thing where you can select what band it's going to be sent on. as well as what the particular transmit frequency in the area there. So pretty cool. Here is mainly if you happen to be using a non-Nextion screen, and you're using like the traditional LCD 16:2 LCD screen, you could. This is where you would probably want to kind of set up of things. You're going to need to know if it's an I2C LCD as opposed to the Parallel, which is the default. You're going to want to run the scanner and find out what the address is. So here I find out that I have. I'll stop here because we don't need to keep going. I actually have the EEPROM at 50, and I have the SIS 351 at 60. Turns out I'm not using an I2C LCD, so nothing very interesting. And there's some options down here. Now, one of the things I want to kind of point out is that everything has a tooltip. So you come down here and you're not sure what's this tuning method means. Well, it kind of tells you what it is. And by the way, you probably don't want 200 kHz. You probably want band, so that when you go to the next band, it goes to the next band as opposed to going up 200 kHz. The KD8 CEC also has the concept of an SDR. I've never been really happy with that, so I'm not sure I'm going to spend a lot of time on that. Now, this is kind of a very interesting area here, which is that there's two things that are going on here that you might want to eventually use. First of all, they have this concept of extended keys. Everybody knows about the KPod that Elecraft has, where you can change the tuning, and you can also hit some buttons and something will happen. Well, this is how KD8 CEC does that. And basically, you can choose what happens when key 1 is pushed, or what happens key 2. And the interesting thing, the way this works, is that it works by basically a resistor network. So each of these keys that you have here has a different resistor, and that's read on the analog to digital channel, and you can kind of figure out where where you need to put the start and the end for that range for that particular resistor. If you look at my GitHub page, I actually have a design for I think it's a 10 key pad that you can actually produce if you like. And here's how you would use the ADC scanner here, so you could actually see what's going on. Right now, the switch is at 1022. If I push it in, you'll see it goes down to 17, and then it goes back up after I go. What you do in this case is you would push the buttons down here, and then you would watch where that value ends up. Very neat little kind of capability here. The other one that is kind of missed, and it has some very interesting kind of feature, is this low pass filters. Now everybody thinks, well, gee, this is just a way to hack the low pass filters by band, and that way I can if I'm concerned about some pollution at some point, I can use this to try to reduce any type of spurious capabilities. However, the other thing that this thing provides is it provides the ability to toggle these 4 digital outputs. They happen to be used for the LCD, so you can't use this and the LCD. But for example, you could figure out where the high and low frequency is for various areas, and then you can click here, one here, one here, and here, and this can be monitored by an external device and use it to switch like bands on an external filter or on an external amp, or even an antenna. You can use that to control this. So this is a very interesting and kind of underused capability. This is the one which everybody kind of has issues with. I'm going to do a separate video just on this one. But basically, this is where all your calibration happens. So there's the master calibration, which is how you get your frequency. Remember the tooltip. There's this, which is always known as the BFO, and that's where your normal kind of voice SSB is adjusted. There's one for CW. Then down here, even farther, you can use this to adjust when is it detected as a dot key or a dash key. Again, it also does this resistor type game. And that's how it detects whether a dot or a dash is pressed. I also on my GitHub have a little small board that can be used to put some resistors in there, and you can twist it and adjust these values. Finally, if you put an S meter on here, this one is not the external data card one, but rather it's the one where you have a sensor hooked up right to your Raduino, Raduino. I'm not going to get it today. And so there's an assistant here that'll pop up, which allows you to manually enter the minimum and maximum, and then you can kind of choose what curves you want between the minimum and the maximum. And you can, of course, adjust these things too, and then you can apply them. And now you have a new, you can adjust where things happen when you go to your S meter. So pretty cool. I think the star of the show here is this calibration wizard, because everybody has problems with this. I'll show this in the next video. Finally, there's also system information. One of the things that I've always kind of been frustrated with is just trying to figure out what release is this particular system running, and when was it built? What is the functionality that you get through the encoders? What are the, what is the hardware? In this case, it was for a Teensy 4. What is the board that it was built for? In this case, it was a V3. What's the baud rate for the Nexion? Are you using an onboard sensor or a daughter card? As you're talking to your Nexion, either through a hardware or the Teeny software library, and where's the EEPROM? Is it external or an I2C? And is the encoder analog? Well, it is in this case, but there are other ones like the Raspberry Pi Pico where it needs to be digital. And then down here, you'll see a bunch of other kind of values too. Now, you notice that some of these are grayed out and some of these are bolded. The ones that are grayed out are actually signed but not used in the header file. So that just reminds you that what those values will end up being used for. So, and then, believe it or not, just like your phone bill, they track what you've been doing lately. The uBITX, the uBITX running KD8 CEC actually reminds you of what was the last frequency you used on this band, and what was the mode. So very similar to that. So let me show you. This happens to be the Teensy, but I also have hanging around a normal Nano on an OEM V6 board, and that one I believe is a 9. Let me read that in. So now you can see we're reading it in again, and now you see that it's a V2 system. It's an internal 1024 bytes Nano, and this is what's in this on this EEPROM. I'm back to my 10, 20, 50, 100, 1,000 type tuning range. So this is kind of cool. And the other thing that's kind of nice about this is, remember I had, I could go back here. I'm not going to, but I could go back here and I could read in from one microbit radio, and then I could write out to another. And the other thing I can do too is I could actually, once you kind of get things going, you want to see whether it worked or not, you can reboot the microbit right here. There's various protections here. There's concept of factory calibration values. It doesn't let you write it unless you kind of say, I'm going to do it. It's also checked here too, where you can copy the factory to your existing value, but you can't go here. You can't go backwards unless you enable that. And of course, the normal nag warning saying, don't do that unless you know what you're doing, and then you can copy it back. So that's basically it. There's as far as help, the tooltips are better than the help. There's a nice PDF user manual which goes through all this. I know I tend to talk very fast. And by the way, if you ever decide you want to know what you did here, you can copy the log to the clipboard. So that's all. Hope you like it. And there's versions of this that are for Windows, for macOS, And there's also a variety of Linux. I probably guessed what all the different Linuxes, but basically, if you have a Debian or a Ubuntu, and including the Raspberry Pi, I probably got you covered. So the GitHub will be where you can download this. Will be down in the notes here, and I hope you enjoy it and that works well for you. Thank you very much.